So my name is Jacqueline Russell. I'm the PM on the Microsoft MakeCode team.
I'm Shannon. I'm a dev on the Microsoft MakeCode team.
And Eric asked us to talk a little bit about how we think through some of our block design. So that's what we're going to be talking about today. What I thought we would cover is, one, give you a little bit of a background on MakeCode for those of you who may not be familiar with what it is. But then we're going to dive right into block design and how we think about it. There's some key principles that we try and think about, as well as a process that we go through. And we'll also give some examples of that too. And then Shannon will show you a little bit about our extension model and how you can create also custom MakeCode blocks. And it's too bad Gabe isn't here today because I put that picture in just for him. So that's the Q robot from Wonder Workshop that we support with the code editor too. All right, so first of all, what is MakeCode? So we're a free open source platform for computing education. We support 7 different code editors today. We started off with physical computing, so microcontroller devices like these here. This is the Microbit and the Circuit Playground Express. And we were really trying to make physical computing more accessible for anyone. But then you can see we've kind of branched out into robotics and games since then. And all of our stuff is online. These are sort of the core product design principles that underpin this product. I won't go into too much detail. This is a little bit of a marketing slide, but really we want to make sure that anyone in any classroom could use MakeCode. So it's web-based, so cross-platform, nothing to install or download onto school machines. It's free, and we also support offline scenarios as well. Inclusivity and equity is a big focus for us. So we try to make sure that all of the content we produce, all the tutorials, everything appeals to a wide range of types of students. And then we're also focused on a progression path. So we have block and text-based editors. And then, of course, we also are a platform as well. All right. So this is our architecture slide. There's a lot of things going on here. So you can see our 2 editors, our Blockly and Monaco editors here. You can see our in-browser compilation chain, as well as our simulator. So, but we're not going to talk about any of that. We're really just going to be focused on Blockly for this talk today. All right, so MakeCode blocks. So we have about 983 different first-party blocks. So these are blocks that we've created ourselves. And there's about 800,000 blocks of code that are written with MakeCode per day. And we're in 182 different countries as well. So we do a lot of investment around localization of our blocks as well. All right, so what are our block design principles? So we have 7 of them. Maybe I'll take the first couple and then hand it over to you. Does that sound good? Okay, so seven core design principles. So first is consistency. We try to be consistent with ourselves. So previous versions of MakeCode, we try not to change blocks too much, as well as our other editors. So in this top one here, top example here, you can see we've got 2 different blocks, one for Lego and one for the Microbit, and they look very similar. We try and be consistent with ourselves, but also consistent with other editors out there that students might have been using. Like, so for example, this is Scratch. You can see the play sound block looks very similar. So things like that, we try to maintain consistency for students. The second key principle is intuitive. So we try and make sure that it makes sense for kids. And there's a lot of temptation to make those decisions ourselves, but we're not our customers. And so we always try and put stuff in front of kids a lot. And then one other thing for kids is, an image is worth 1,000 words. And so we try to make our blocks as graphical as possible. So these are a couple examples. This one is the Circuit Playground show ring block. And actually, Sam, you can chime in because Sam designed this block. So it looks very much like the Circuit Playground. And so it's very intuitive for kids to design. That other one up there is a Minecraft block. So again, being able to see what the block looks like. And then the Lego is just all the 3 different types of motor configurations, essentially. Thematic. So again, domain matters. So whether you're working with a robot or a game, it's really important. And that helps define the block. So for example, this one up here is a Minecraft block. This on chat command. Minecraft has a chat window where you can issue commands into the game. And so you won't see that in any of our other code editors. So, or like this little chicken spawn egg here. So we actually wanted to show the real animal so they could help pick what animal they wanted to spawn. But the Minecraft team pushed back and, it's not the Minecraft way. You have to show spawn eggs. And so that's why they all look like eggs. So we work very closely with our partners to determine the requirements for these types of blocks. And sometimes they're in conflict with the consistency principle, right? So this is the Lego blocks here, and you'll notice we've got this pause until block. We wouldn't normally have that kind of block because we're event driven, right? So we would just have a top level event handler, but because of the way Lego Robotics works and some of their requirements, that we included that type of block as well. So do you want to do this one? Okay.
Sure, yeah.
Okay.
So we also try to keep in mind sort of like the MakeCode way of thinking about things. So like Jacqueline said, we're event driven. So all of our code is inside these top level event handlers and they're run when something happens. So when a button is pressed or when so when a button is pressed or when the microcontroller board is shaken.
Yeah, and this is in direct opposition to the way things are done in the microcontroller world. So those of you working with Arduino, where it's really just about polling, right? So this is very different.
Yeah, and then the other thing is that all of our variables are specified in the global scope. So anything set in this onStart block can then be accessed by any other block in the workspace.
So this is where we differ from Scratch, say, for example, where you do a lot of the coding. It's sort of object-based, right?
And then we try to aim towards a what you see is what you get. So we avoid these higher order abstractions. So you'll see this is a code.org snippet that spawns a cat, animates it dancing in the middle of the screen in one block. And the same code in MakeCode would require the student to create a cat sprite and then add frames to that animation and then start the animation. So that's obviously more code, but the hope is that by letting the student construct the animation, they understand sort of the plumbing that goes on underneath it. And it gives them a little more freedom in designing their animation as well. So that's sometimes in tension with the idea of being intuitive. So it's always a trade-off between how easy it is for the student to do a thing and how granular we want our blocks to be. And then our code editor works one-to-one between blocks and TypeScript. So students can write in blocks, switch to TypeScript, edit the TypeScript, and then come back to blocks to have those changes persisted. So we want all of our APIs to be aligned and really consistent across TypeScript and the blocks themselves. So we use the same namespaces as we use in the jars in the toolbox. And then we want the names of the functions and APIs to be the same as the text on the block. And in general, we want them to be very, very robust because this is a platform for kids. So we want all of our blocks to be plug and play. They can drag them anywhere. The blocks should work. Students shouldn't be allowed to, connect to blocks that then cause errors or break the program. So you see this set all pixels block. We'll set all of the pixels to red, and you can put it inside an event listener or button handler or the onStart, and it will work the same no matter what the top level block is.
Yeah, and you can plug in different ways of setting that color, right? So as you can see, it's got multiple embedded blocks there.
And then we want our platform to be really extensible. So in general, we have like a base starting set of blocks, and then we let partners, extend, or we ourselves will make extensions that people can add on. So here is our radio blocks. And you can see on the event handler, you send a number, and then we have a listener. So when the radio receives a number, it executes some code. Um, and then this is the radio broadcast package, which actually allows students to create events. So in sort of an enum form, so they can create a start event and then send that, and then have a handler for when the radio receives the start message. So it's sort of the same general concept, but with maybe different block structures or setups. So we let people customize it in that way.
All right, any questions on sort of the core principles? And we don't always get this right, so but we try to think through some of these things when designing new blocks. Yeah.
How do you come up with
The principles organically. It's not like we sat down, we're like, hey, here are your principles. It just kind of unfolded, like after creating so many different types of, oh, sorry, do I need to repeat the question? Okay. The question was, how did we come up with these 7 principles? And I would like to say it was very planful, very thought out, but it was not. It was just kind of organic. Having gone through this so many times, this is just kind of what kind of came up as we thought about it. I don't know, Shannon, if you want to add anything else.
Yeah, I think you do it a couple times and you run into issues, and next time you're like, oh, okay, we have to keep this in mind for the new blocks.
Yeah.
Do you ever come across issues between your goals of sort of WYSIWYG and TypeScript friendly versus sort of simplicity,
All the time.
especially?
All the time.
Yeah.
It's a really tough balance to strike. But I mean, we're lucky that we have 7 different code editors. And so the blocks that we create for Arcade, which is a sort of a little bit more advanced code editor, are definitely not going to be the same ones that we do for the microbit, which are much more simplistic, right? Aimed at a younger audience. So we have that spectrum to play around with. But in general, for example, Hour of Code, you've got this thing that's going out to like tons of kids who may have never programmed before, right? And you've got an hour of their time. And so how do you create an experience that is impactful and they're engaged and happy with what they've created, but also make it super easy? It's tough. Yeah.
Yeah. You mentioned that you can you mentioned that you can actually like switch from the block-based editor to a TypeScript view.
Correct.
How do you handle the other direction? Like if I like edit the TypeScript, I can add some really weird stuff there. That's a valid TypeScript. Yeah. So what do you do? Like, do you have one-to-one correspondence?
Where we don't have one-to-one correspondence, we turn those into gray read-only blocks if we can. Yeah. And we can demo some of that a little bit later, or you can just go to our website and check it out for yourself. I'm just going to move on really quick to the next section, which is really around the design process that we go through. So first of all, I want to say that the process will be a little bit different based on if you're thinking about designing a whole set of APIs. Like, so for the example, this is for Minecraft, where we were trying to, build basically a library of blocks versus for a single block design, right? So when you're designing an API, you have to think about all the different options and how the blocks work together. But in general, the process that we go through is someone builds something. Someone on the team takes a stab at it, builds something, and then we go through these design sessions. So we have sort of office hours with a designer that we work with. And we go through and we tweak it and we kind of try different things, look at different things. And then we put it in front of kids, as many kids as we can. And luckily there's a very active parent alias at Microsoft. And so we have a lot of kids that we can kind of test on. And then we also get a lot of feedback and bugs from the community. that help us iterate through those new blocks. Okay, so some examples of how we've done this. So first of all, this is the microbit radio blocks revisited. So what was happening with the radio blocks with the microbit is you can see we've got a couple different types of radio received blocks. You can either receive a string or you can receive a number. And under the covers, these are just variables. And so what was happening is users will pull out these are actually different blocks, but users will pull out like a received number block and then just rename the variable to received string and assume that would work. So actually a lot of people were doing this, and so it was a big issue. And so we were trying to figure out, how do we fix this issue? We came up with a few different potential solutions. So idea one was using draggable parameters. Idea two was actually making the blocks very different. So actually putting like received number on the actual block so people knew that was the received number block. And then idea three was like to have one block to rule them all, where you just have one radius receive block with three parameters that you couldn't change. I liked idea three, but I was overruled for a multitude of good reasons. But we went with idea one, and then we went through the design process of what that should look like and how to build affordances so kids knew that they could actually drag out those parameters. Do you want to talk through this one?
Sure, yeah. So this is our music API. So initially we had two blocks, one to play a preset sound. And so this is a drop down of a bunch of different like short sounds. And then one to play a single tone for a length of time. And so we had an intern this summer, and her project was to design a field editor that would let students compose their own like little melody inside the blocks. So this was our initial design, and then we looked at existing melody editors. And we sort of went back and forth iterating on the general concept of like, oh, you want a grid with maybe different colors for each note, and students should be able to control different things like tempo, and they should be able to loop their melody. So this was our end result, which is this melody editor grid. And then up here, it's got a shorthand representation of the melody using those colors. And one of the other editors that we have is this sprite editor. And so this is for drawing sprites in Arcade, our game engine. And so you can see how the melody editor sort of wants to stay consistent with that sprite editor layout. So with the editor and the gallery tabs, the general like square layout, and the buttons along the bottom.
And we do a ton of user testing too. So we do user testing. We either bring kids in, or like, kids that are local, or, from the parent alias, and we'll do one-on-one sort of user testing, or we'll go out into classrooms and do classroom observations. So that's super, super helpful, because you never know until you put it in front of a 14-year-old, right? So, okay. I think, what else did we have here? Oh, right. So Shannon, you want to talk a little bit about?
Yeah.
You can just hit escape to get a discard. Yeah.
So we allow people to write their own custom sets of blocks, and then you can actually, there's a process for loading those into MakeCode as like a package. So you can write tutorials or like have lessons with your own blocks. And so if you go to makecode.com/playground, there's a sort of workspace for you to iterate on block design really quickly. So you'll see here, this is a TypeScript editor, and each block corresponds to a function in TypeScript. And then over here is a Blockly workspace. So the flyout has all of your custom blocks. You can drag them into the workspace, interact with them. And so all of our blocks are defined using this // annotation. And the // block is the most important thing, because that defines specifies that this function is a block. And then we have this nice convenience thing where if you name your function in camel case, we'll split that up and use each word as the actual block text. But say you want, you can also specify different block text. So I type that and I use block equals the string. I hit run up here and it will regenerate the block with the custom text. And then if, say, this function takes an argument, so I would go over here. And then $sign count references the argument by name. So if I hit run, now this function has an input and it knows that it's a number input because this is TypeScript, so we have types. So oops. If I change this to be a string, then it's a string input. So some other nice things that you can do. If I do text.defl, which is default, I can specify default values for these blocks. If I take this and say I want to make another set of blocks. So up here, this // color specifies the color of this namespace. So color. And this will generate a new block, different color, different text. And then if inside this block I have a return value, we detect that you are returning something. So now this is a reporter. And one more fun thing is in here, I can give this block an ID, which is just any string. And then up here, I can specify the shadow value using the block ID. And so now this is a block with a shadow value. These are both string blocks, so I can drag the string in and out of it. And so that's how you can kind of really quickly like iterate on and play with our different blocks. So in this dropdown, we have a bunch of different examples showing how to do, how to use our different macros. So let's see. Types of blocks has, the input, the Boolean shape, and event handler is just a function that takes a function as an argument. So if you add that argument, it will change the shape of the function so that it takes a stack of blocks. Let's see. If you have an enum list, it's rendered as a dropdown. And this is just the dropdown with like the values of the enum. If you specify / block over each of the enum entries, you can give it sort of human-friendly text. So so that's nice because then you can have like cleaner code-friendly values in your enum and then like user-friendly values in the dropdown itself. But yeah, we have, these are the Blockly field editors. So if you add a min and a max to the number block, if you drag it out, we will give you a slider with those min and max values. And all of these different field editors and block shapes can be combined to make like a set of custom blocks for whatever your scenario is.
Cool. All right. Any questions about block design or? Yeah. Okay.
Hi, Jacqueline. This is not a question on block design. Actually, I find it really interesting what you're presenting. I have a question on the technology. Do you have kind of like an API, a library or something that you can use in other kind of environments? Because I like that you told us that there is the possibility of going from blocks to text and text to blocks. I don't know if maybe there is a chance of developing further or building a technology with MakeCode as like a library or as an API with that functionality.
Yeah, I mean, we're open source. I don't know, Shannon, if you want to comment on the difficulty of porting.
So we convert between blocks and static TypeScript, which is sort of our own like subset of TypeScript that our compiler understands. So it isn't really between blocks and like any language and then back. it's pretty specific to our.
But we have
stack.
had partners that did use MakeCode in other ways, and so just sort of embedding it into like not our official code editors, but into kind of what they're doing. So so we're happy to talk to you to see if you wanted to use it in some way. Yeah.
I want to ask real quick, do you apply those same principles to the TypeScript APIs that you design as well? And how do you test those?
Yeah, I mean, it's one and the same, really,
Yeah.
because I mean, TypeScript is the truth. So yeah. I don't know, Shannon, if you want to.
Yeah. No, each API corresponds to a block, so happy to iterate on those as well.
On that note, I'm curious if you ever have pushback about the TypeScript that you're generating not being, kind of idiomatic TypeScript. Like I'm very much on the block side. Like, yes, we should, global variables and we, whatever the semantics work in the blocks. But is there ever pushback that, is there trade-offs between those two that you have to deal with?
Yeah, I mean, so the TypeScript team sits just down the hall from us, and they think that we're a little bit crazy, like what we're trying to do, but they do think it's really interesting. For example, the rest of our team that's not here is actually at TSConf presenting static TypeScript and sort of what changes we've made to the language. I think we are an educational product, right? We're focused on learners, which is different from the strategy that TypeScript is going after. And so we don't get a whole lot of pushback around what we're doing. Yeah.
So this may be a question not just for you, but also for Eric and Rachel. I understand there's some efforts underway to sort of integrate some of the MakeCode stuff with the Blockly core and all that. And I'm just wondering, are there any grand plans for that? I mean, for example, how interoperable might it be? Would there be a day where you could use this playground, but it would create stuff that looks more like what the standard Blockly developer has? Is this generating stuff that fits with them? Just kind of curious about the general plans around that integration.
You want me to take that?
Yes, please.
So, Rachel wants to take.
Our plans are really grand. They're using the same block definitions behind as normal Blockly blocks, and we are trying to get it to where their renderer is completely or almost completely in core Blockly. The result of that is that you should be able to switch back and forth. You should be able to switch back and forth between the two styles of what the blocks look like while getting the same, it's the same actual block. We haven't talked about doing this more complicated stuff with the actual block definitions involving the TypeScript annotations, though.
That's what I was kind of wondering about. Sort of, there's an ecosystem around Blockly, and there's sort of an ecosystem around MakeCode, and I'm just wondering if there's plans for any integration at that level.
The eventual goal is that MakeCode no longer has to have a fork of the Blockly UI library. They can just have a few files that define their custom fields that are specific to MakeCode, and otherwise all of the rendering for blocks can just be provided by Blockly.
Yeah, and we are working towards that goal. I think we collaborate a lot together, and Sam's over at Blockly now, so it's going to make things happen.
But as far as, for instance, pulling in those block definitions themselves into Blockly, I think that's part of what you're asking. And having that as part of Blockly's library of blocks. We right now have only blocks that are really, really agnostic to language. We only have blocks that we support in all 5 languages and so on. I see that continuing. We are going to try to get more of a, yes, we are pulling in, we're pulling in fields from them. Yes, for sure.
So you generating your toolbox dynamically as well. Do you ever have a situation where you want to have multiple blocks connected together in a toolbox? Is that supported at all, or do you have to make the design decisions to have all blocks individual, standalone?
Yeah, no, we don't have a scenario where we have pre-connected blocks in the toolbox. We do have scenarios where we have default blocks on the workspace as like starter code, like in tutorials and stuff. But no, we hadn't.
So in like regular Blockly, there's generators and you get like you can get like a code file at the end. I'm kind of curious. Is there like a code file at the end, or is there like a final product that you can export to? Like say you're building like a web server, or a PHP file for a web server. Is there like a PHP file? Is there or a Node file for Node TS server, whatever. Anyway, say you're building something like that. Is there something that you could like export from this platform, like a code file of some sort?
From the playground, or just in general, how do you build extensions? Just in general. Yeah, so we have some pretty good documentation on building extensions for MakeCode, and it goes through sort of what you need in the process. I don't know, Sam, if you want to add anything to that.
Yeah, like we're in a project, everything's getting compiled down to TypeScript. So that is your output. Now, MakeCode would go ahead and go down in some editors and compile that down even further to some ARM assembly that runs on some of these microcontrollers. But TypeScript is kind of what's being compiled out of the user code that the user's writing in, whether it's in blocks or TypeScript.
For Arcade in specific, I believe you generate a assembly file that, or a hex file that then can be copied over.
So user code, is that what you're talking about?
Just more like do you get a file at the end of it? Like with Blockly, I get like a file that I can upload to something or do something like that. Is there like with like a generator, is there like a process to get a file out of all that?
So for students who are coding in MakeCode, and they code their program, they have it do what they want to do, and they test it in the simulator, make sure it's running right. They click on this download button, and that will compile down their code from blocks to TypeScript to intermediate representation, and then into something that a microprocessor can understand. And that, so we have a couple different file formats. This is hex that's running on here. UF2 is another file format that we use. So yeah, I mean, the program file is a real thing. If that's what you're, is that what yeah. Yeah, and Arcade, it runs on Arcade devices, or you can save it as a PNG actually too.